What's up guys, it's Iman Fiaz and today's video is on transition metals multiple choice questions. So, question 1, which equation does not show the reduction of a transition metal? So if I look at, take up charge. So if I look at these equations, the transition metals, so part A, titanium, so I can see that's a 0, chlorine is -1, down by 4, -4, that's going to be +4 to 0. So definitely there is a reduction of a transition metal. 2, where you don't care about the moles, -3, because -1 of chlorine times by 3 -3 plus +3. In this case, -2, that's going to be +2. So therefore that is a reduction. C, MnO2, -2 times by 2 -4, therefore Mn is going to have a +4 oxidation state. And in this case, MnCl2, that's going to be a +2, because -1 times by 2 -2, therefore Mn must be a +2. That is also a reduction. And therefore D is obviously the correct answer. But let's look at it. So that's obviously going to be -2, that's going to be +2. Whereas in this case, this one's a bit more different, but Cl is -1 times by 4 -4. That's going to be +2 because the overall charge is -2. So there's no reduction. It stays the same. So therefore the answer is D. Question 2. This one is a bit of a cheeky question. Which will not act as a ligand in a formation of complex site? Ligand is one that can donate a lone pair of electrons, right? So if you look at A, B, and C, and D, well, I know D definitely can, because obviously NH3 with lone pair of electron NH4 plus, that can act as a ligand. H2O, again, that can also act as a ligand. It's got 2 lone pairs of electrons. Now I'm left with A and B. Well, if I look at carbon monoxide, it also has a lone pair of electrons, so it can act as a ligand. And the question says which will not act as a ligand. CH4, it's got no lone pairs. Carbon can only form 4 bonds. So it's literally just going to be like that. There's no lone pairs to donate. Therefore the answer is A. Question 3. Which row shows the correct oxidation state and coordination number of cobalt in this? It's very tricky. But it hasn't given me a a charge for this ion. So I know the overall charge is going to be neutral, right? So if it's neutral, overall charge is equal to 0. Overall charge is equal to 0. Okay, so CO, NH3, 5, Cl, Cl2 on the outside. And I want to find out the oxidation state of CO, and then I'll focus on coordination number. But first, let's just work one at a time. So NH3, well, that's going to be neutral, and therefore that's just going to be 0. So we'll say let CO equal Y. So I've got Y plus 0 plus, well, chlorine, that's -1. And what is that equal to? Well, because that -1 out on the outside, actually -2 because there's 2 chlorines, therefore the overall charge must be equal to +2. Because, like I said before, the overall charge is neutral, therefore is equal to 0. So therefore, because I've got a -2 on the outside, it must be a +2, the overall charge. So then that will give me 0. That's probably one of the hardest parts to wrap your head around. Once you've got that, then it's pretty easy. Because then I think about it, okay, therefore Y is just going to be 2 plus 1, which is +3. So I know the oxidation state of CO is +3. Now I'm left with how many coordination numbers? 5 or 6. Well, I've got a ligand here, NH3, and there's 5 of them. And I've also got this Cl. So it's going to be 6 coordination numbers. Question 4. Which statement is not correct? CuCl4 2 minus is square planar. NH4 plus is tetrahedral. That is octahedral. I'm not going to say the name of it. FeH2O6 2 plus is octahedral. CuCl4 2 minus is square planar. Definitely not. That is definitely not correct. I think it is octahedral. It's definitely not square planar because of that 2 minus. Yeah. NH4 plus tetrahedral. Yeah, that's a pretty easy one. This one, yep, and that one, yeah. So the answer is A. Question 5. Which compound decolorized acidified potassium mangate 7 solution? I'm left with A, B, C, and D. Now, if we look at FeSO4, the answer is going to be C because we'll look at the, that's minus 2, minus 4, minus 8. It's going to be Fe2 plus ion to go to Fe3 plus ion. So that would oxidize 2. So therefore, it would decolorize this. Question 6. A bit of a wordy one. What is observed when concentrated hydrochloric acid is added to an aqueous solution of copper sulfate until no further change occurs? A colorless gas is evolved and a precipitate forms. A colorless gas is evolved and no precipitate forms. Both of those are wrong. A precipitate forms that dissolves in excess of concentration of hydrochloric acid. That's wrong as well. The solution changes color and no precipitate forms. That's true. Question 7. You do need to know the observations and all of that. I don't even know them. But you do need to know them because they come up a lot of multiple choice questions. In reality, you could do trial and error, but if you just knew the reagents and the conditions, you could find them out. And trial and error won't give you a 100% guarantee of getting it correct anyway. Question 7. Which statement is correct about this reaction? The coordination number of cobalt decreases. Cobalt, so it's got a coordination number of 6 in this case, and then here got coordination number of 1, 2, 3, 4. Because there's 3 on the outside, so that'd be 12. So it definitely doesn't decrease. The enthalpy change is large and positive. Remember, for enthalpy changes for these ligand substitutions / exchange reactions, enthalpy change is not large and positive. It's very, very small. Entropy change is large and positive. Let's look at entropy change. Well, I've got 1, 3 here, so that's 4, and I'm forming 1, 6, 7. So yeah, the entropy change will be large and positive. Shape of the complex changes from octahedral? No. Question 8. Which complex exists as optical isomers? I think that, yeah, question 8. There is a mistake with this one because that's Tollens region. That's not going to exist as an optical isomer. Some silver complexes can form 2 coordinate bonds, but that they can't exist as optical isomers. And in this case, it's not going to be it. It's actually B and C. So that's not really a multiple choice question where you choose one. And yeah, the answer is B and C. So whichever one you go for, B or C, get correct. Which is not a correct statement? Transition metals form colored ions and complexes. That's definitely true. Transition metals display variable oxidation states. 100% true. A ligand accepts a pair of electrons from a transition metal. That's false. Donates. A complex is a central metal atom surrounded by ligands. Perfectly true. Question 10. Cisplatin, you should have studied this, is an anti-cancer drug. Which structure represents a stereoisomer of cisplatin? So it's a complex of platinum 2 with 2 chloride ions bonded to it, and also 2 ammonia molecules in a square planar structure. So a stereoisomer of cisplatin. Cisplatin, so they are opposing each other, the chlorines. Oh, this is actually really nice question, because I can already eliminate C and D. NH2, NH2, NH2. No, it's NH3. Now I'm left with A and B. But remember, if it's a stereoisomer of cisplatin, well, then it's got to be the ones that are opposing each other. This is a trans isomer, and therefore it's going to be a stereoisomer of cisplatin. They can't really ask you that many questions about cisplatin. Describe how it works, a big 6 marker, and then just a couple of multiple choice questions. Question 11, which ion is most likely to be in the solution? The answer is D, Cu2+. And I'm pretty sure, actually no, well, that's obviously orange. I'm not sure about the rest, but the answer is D. Question 12. What is the electron configuration of copper 2+? So remember, copper 2+, if I get the periodic table out right now, and I can actually just go through it full. So copper has got 29 electrons. However, because of this 2+ charge, you have to minus 2, and therefore I'm left with 27 negatively charged electrons. So now if I try to do this, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4, 10, 12, 18, 20, 4s2, 3d7, 4, 10, 12, 18, 20, 27. Okay, that's electron configuration of Cu2+. But obviously remember, 3Ds actually are slightly lower energy than 4s. Or is it the other way around? Anyway, what should happen is that it prefers a more / full, sometimes, occupied 3D orbital. So what happens is these 4s2 electrons go to this, so that becomes 3d9. The answer is AR 3d9, because the electron configuration of AR is 18, 2, 4, 10, 12, 18. Perfect. Question 13. Electrons in copper 2 ions can be excited by the absorption of light with a wavelength of that. What is the increase in energy in joules for each electron excited? This is nice because it gives me the speed of light, Planck's constant. I don't know if they have to give it you, but I would memorize it anyway. Obviously the units as well, not just 3.00 times 10 to the power 8. What units are the meters per second to the power -1. But anyway, we need to use a formula: increase in energy, size of energy graph. Delta E is equal to HV, which is equal to HC divided by wavelength of light absorbed. Now H I've got C I've got. So it's just going to be 6.63 times by 10 to the power minus 34 times by 3.00 times by 10 to the power 8 divided by the wavelength of light absorbed in meters. It's giving me in nanometers. So what I have to do is I have to times by 10 to the power minus 9, aka divide by a million. Divide by a billion, actually. Yeah. Do that. Put it in a calculator. Boom. Let me do that. 6.63 times by 10 to the power minus 34 times by 3.0 times by 10 to the power 8 divided by 600 times by 10 to the power minus 9. 3.32 times by 10 to the power minus 19. The answer is D. So this question, all it needed really, you to memorize the formula and also convert between nanometers to meters, and you should get the answer. So not an extremely difficult one. And question 14. An oxide of vanadium catalyzes the following reaction. SO2 gaseous state plus a half O2 gaseous to a reversible reaction SO3 in gaseous. So what is the formula of the vanadium containing intermediate formed in this reaction? Vanadium containing intermediate, you need to know, what's this called, the contact process. You need to know the contact process and all these equations like the back of your hand, and then you should get D, because you could recognize it easily. Oh, that's the vanadium containing intermediate, because I remember this equation. And that is the end of these multiple choice questions.